Do you know how many devices are connected to your home Wi-Fi right now? Your phone, your laptop, your TV. But is there a device on this list that doesn't belong to you? Today we'll find out. In today's video, we'll use free tools to conduct a complete security audit of your network. At the end, you'll be able to say for yourself, yes, my network is secure, or no, I need to fix it now. You might be thinking I'm just a normal person. Why would a hacker target me? But the reality is, hackers usually scan randomly. A network with a default password, a router with old firmware, that's their first target. From a compromised home network, hackers can steal your banking information, get access to your camera, use your internet connection for other purposes, control your smart home devices. But the good news is, it's easy to prevent all of this. Let's get started. First thing to do, enter the router's admin panel. Try these two addresses in your browser, 192.168.1.1 or 192.168.0.1. Login default username admin, password is usually admin, admin123. All right, we are login. The very first place you need to look is the connected devices or DHCP client list. Take a close look at this dashboard. You are seeing every single phone, laptop, and smart device currently using your network, along with their assigned IP and MAC addresses. If you see an unfamiliar device, change the password immediately. Now, let's go deeper. We'll use Nmap, the world's most popular network scanner. If you're using Windows, you can use its simpler graphical version, Nmap. But to do the job like a real security expert, we'll switch to the Kali Linux terminal. First, we execute a subnet sweep to map out every active device on the network. Look right here. The quick scan is complete. We can instantly see exactly how many devices are connected to this network. Every IP address, MAC address, and device manufacturer is now completely visible. Now, let's target this mysterious unknown device from our list. We are going to run an aggressive, all-port scan to see exactly what is running under the hood. Look right here. The scan is complete, and it reveals that port 2221 is wide open, running an FTP service. But it gets much worse. Notice this line, anonymous FTP login allowed. This means that an attacker on this network will be able to access the device's internal folders, DCIM, pictures, and downloads, without a password. This is exactly why a forgotten open port is a huge security risk. However, it's not as easy as it looks. I'm just showing this for educational purposes, thinking that you can do it yourself. There are many things that can't be shown directly, so I'm just giving hints so that you understand how to do it. Then with a little research, you can do a lot of things yourself. Now, let's run a standard port scan on our target server. We simply type Nmap followed by the target IP address. This is a fast and stealthy way to see what's exposed. In just a matter of seconds, Nmap reveals exactly which doors are left wide open on this machine. Look at this massive list. We have FTP, SSH, Telnet, and HTTP all running simultaneously. Just knowing these specific ports are open is the critical first step an attacker takes to compromise a system. Scan another device connected to our Wi-Fi network. To make this easy to understand and perfectly safe, I'm using a connected Metasploitable lab for this demonstration. I highly encourage you to do your own research and try practicing this on your own local devices. The scan is complete, and the results are terrifying. Look at port 21. It allows anonymous FTP login, meaning anyone can access files without a password. But here's the ultimate red flag. Look down at port 1524. It's running a direct root bind shell. You don't even need to hack this server. The backdoor is wide open, giving an attacker instant administrative control. Now, let's try to identify the exact operating system on another target using the -O flag. But here's a pro tip. Modern firewalls like Windows Defender often block standard ping requests to hide their presence. To avoid this, we add the -PN flag, which forces Nmap to scan the device directly, bypassing host discovery. The scan is complete. Notice this warning. The device's firewall is active and blocking some of our probes. However, Nmap is still powerful enough to analyze the open ports, specifically 135 and 445, and can confidently identify that this target is running Microsoft Windows 11. The most important step is to identify the service version using the -SV flag. Hackers need to know the exact version of a software to find vulnerabilities. First, I will scan a protected Windows machine on my network. Since its firewall is enabled, I add the -PN flag to force the scan. As you can see, it only exposes standard and updated Windows services. But to really understand how dangerous service detection can be in the real world, let's target our Metasploitable lab. We run the exact same command, and boom, Look at this new version column. We don't just see that FTP is open. We see that it's running VASFTPD2, 3.4, a notoriously exploited version. We see an old Unreal RC service. Hackers take these specific version numbers, look for known exploits, and compromise the entire system in a matter of seconds. Now, it's time to use the basic tools. We're going to use Nessus Essentials, an industry-standard vulnerability scanner used by professional penetration testers. It's completely free for home use for up to 16 IP addresses. After a quick download for Kali Linux, we'll install it via the terminal and start the Nessus service. To access the dashboard, we'll go to localhost on port 8834. You'll probably see a security warning here. Don't panic. Since Nessus uses a self-signed SSL certificate for secure local scanning, this is completely normal. We'll just take the risk, enter our activation code, and we'll be in. Automatic installation will take care of everything from here. You don't have to do anything here. When everything is done, you'll see a pop-up. From here, it will work if you give your testing IP, and from here, it will work if you give it a new one. Instead of scanning just one device, let's scan the entire network. We've set our target range to 192, 168.0, 0/24. Notice that we're not providing any login credentials. This is called a black box test. We're scanning the network exactly as an outside hacker would see it. Scan is complete, and this dashboard gives us a complete aerial view of the attack surface. My Windows PC and smartphone are relatively secure, but look at this target. IP 192.168.0.101. It's glowing red with 10 critical and 7 high vulnerabilities. It's an easy target. And it's even scarier. IP address 192.168.0.1 is the main Wi-Fi router, and even that has 5 critical vulnerabilities. But here's why Nessus is so powerful. If we click on one of these critical alerts, it not only shows us how the system could be exploited, it also provides us with the right patches and solutions to secure our network so that bad guys can't get in. Now, let's look at exactly what kind of traffic is secretly flowing through your network. To do this, we use Wireshark, the industry standard for network protocol analysis. We select our network interface and start the capture. Immediately, we are flooded with raw packets. To a normal user, this looks like the Matrix, and finding a hacker in this chaos seems impossible. But we don't need to read every packet. We just need to know who our devices are talking to. If we go to the filter bar, type DNS, and hit enter, the chaos disappears. Now we have a clean, readable list of the exact website domains our network is trying to reach in real time. But if you want the ultimate cheat code to spot rogue devices, go to the Statistics menu and click on Conversations. Next, select the IPv4 tab. By default, this might just show our filtered DNS traffic. But watch what happens when we uncheck the display filter box. Look at this massive list. Suddenly, we see over 100 hidden background connections. This is your computer silently communicating with servers all around the world. By keeping an eye on address B and the amount of data in the bytes column, you can instantly spot if a smart TV, a camera, or hidden malware is secretly leaking your data in the middle of the night. Now let's see what your network looks like from the outside, that is, from the internet. First, find your public IP. Search Google for what is my IP. Then search shodan.io with that IP. I'm showing you a demo IP. Shodan is a search engine, only for internet-connected devices. If your IP shows an open port, it will be visible to the outside. Today, we did a full network audit in 5 simple steps. First, we checked our router settings. Second, we used Nmap to find connected devices and open ports. Third, we scanned for vulnerabilities using Nessus. Fourth, we monitored our network traffic with Wireshark. And finally, we checked our external exposure using Shodan. Now it's your turn. Let me know in the comments. What did you find after checking your network? Did you spot any unknown devices? If you liked this video, like, comment, and hit that subscribe button for more. Stay safe.